guess I forgot to fix 24.
Yeah, so you undo addition and subtraction before multiplication and division.
Yeah.
You add 5 to both sides, and then off to the right, you have to say addition property of equality. I guess that's what APE means.
Yeah. And then DP is division property of equality.
Right. So you have minus 3x equals 21. And that's just a simplify step, but you don't even need to say that. Like usually you put the result underneath, or you just say addition property of equality to get that. Then you divide by -3. Like that.
Okay.
Okay, so in two-step equations, you always undo multiplication, addition, and subtraction before multiplication and division.
Okay.
All right, so number 2 looks okay. Does your instructor want you to say simplify, or what's the deal there?
No, that's just the justification. He has to say that for justification. And I don't really understand it, but it's just what he wants us to do. So
Yeah, because when you the really the only, excuse me, the only lines you would see would be this line with the arrow, this line with the arrow, and this line with the arrow, and you would just have
Yeah.
start, addition property equality, the result, and division property equality, the result.
Yeah.
But that's okay. So, I mean, do you want to try 3 on your own here, and I can check it after you're done? I mean,
Yeah.
so I guess let me know when you've worked it out, and we'll talk about the result.
All right. So subtract 6. And that's 18 equals 2x divided by 2 divided by 2, x equals 9. And then you have subtraction problem of equality, division property of equality, and then simplifying again. Okay.
So it should subtract 6 from both sides, and that gives you 18 equals 2x, and that's the subtraction property of equality. And some instructors want you to write this out. Is this okay to doing shorthand?
Yeah.
All right, and then you divide both sides by 2. X equals 9, that's the division property of equality. Any questions on that?
Nope.
All right, so why don't you try number 4? One of the things with number 4 that I'll point out, and then is that the subtraction operator goes with that one on the right. You probably know that already, but it's not part of the 8. The 8 is positive.
Okay, so then subtract the 8 first. And then negative 4x equals negative 24. And divide by negative 1. X equals 6, which is division property of equality and subtraction property of equality.
So what's your final answer?
X equals 6.
X equals 6. Okay, so we're going to subtract 8 from both sides. Negative 4x equals minus 24. Subtraction property of equality. Divide by negative 4. X equals 6. That's division property of equality.
Yep.
All right, why don't you try 5? Okay, yeah, why don't you try 5 here? And I'll put up the answer here in a moment.
Okay, so for that one, subtract 8 from both sides, and then divide by -4, and I got x equals 8.
Yep, that's correct. So the way you're, yeah, I mean, it's okay. I don't want to, I'm not gonna get involved here. X equals 8, division property of equality. All right, good. 6 is a little bit different. It's got fraction, but you still undo multiplication. I'm sorry, you undo addition, subtraction before multiplication, division. So you undo the +4. You always look at the side with the variable. I guess that's more generally what I should be saying is you always look at the side with the variable, undo addition, subtraction before multiplication and division.
Okay, so then with this one, subtract 4,
Right?
and you get m/7 equals 4. Then you get m equals 28.
As you multiply both sides by 7. And so you get m equals 28, multiplication property of equality. Don't know if we've covered this strategy for the next problem, the error analysis. What I recommend to students do, and I know this is hard because you really want to look at the answers. You want to actually work the problem out without looking at the answer. Like you actually want to, if you could, take your hand and cover up the answer. And you just work it out, and then look at the answer, and then see, okay, well, what's the same, what's different? So that's my suggestion. Or you can look through the steps and try to figure it out. It gets harder to do as the problems get more complicated, but I'll leave that up to you to tell me what the mistake is.
Okay, mistake. Forgot a negative. Should be
So
-1.
what should it be?
-1. X equals -1.
Yeah, and that is the mistake there. So some instructors really like these types of problems where you have to find the mistake. Sometimes they give you problems where like they'll give you one that's correct and one that's wrong, and you got to figure out which one's correct and which one's wrong. Just depends on the instructor. So this is a 4-page assignment, or it's like you're supposed to do 1 page per day. Like what's kind of the style of the homework?
Yep, that's
Do you get
pretty
1 page
simple.
per day, or do you get like this whole packet to do for the week, or
No, this was it.
just this 1 page?
Yeah,
Okay,
that was it.
all right. Yeah, this is really slow, really moving really slow. That's okay. So we can do some more advanced problems of this, like we can extend the concept by working on more complicated equations. We could do like more like standardized test prep. What would be best for you?
Um, not sure because like he doesn't post what we're gonna do in the future.
Okay.
Um,
So the next topic that you typically get when you're solving equation is to combine like terms.
Yeah, we
Nice.
did some of that in like our notes where we had x, like 4x plus 3x plus 7 equals 16 or something like that.
So here's an example of a problem where you have to combine like terms. So on one side of the equation, you'll see variables and you have to combine them first. And it's usually the variables, but it could be numbers. Okay. So like
Okay.
here you would say, okay, I'm going to combine those. That's 1x minus 5 equals 7. And then you would add 5 to both sides to get x equals 12. All right, so that's a pretty basic example here. Let me find some better problems for us. Give me just a moment here to find some. One of the reasons you guys are in school for so long is because you don't, it takes you time to just get through stuff like this. Because it really can be covered pretty quickly when you
Yeah.
got a good, good math background. So, um, here's a pretty trivial example here. I'll put up here again. You can try this. So on the left here, you've got variables that you can combine.
Okay. So should be n equals 2. It was like a
So
really
so it's
simple one.
2n equals 4. Then you
Yeah,
divide by
n equals
2,
4.
n equals 2. All right, good. I'll be right back with you. I'm going to put up the problem in the meantime.
Okay.
Okay, why don't you try this one here? If you're not already.
So then 7v, so it'd be m equals 2, or v equals 2, sorry.
Not quite. You got a small
Or v
error
equals
there.
7, sorry. I meant
It's
7.
still same. Still not quite correct. So did you combine these first?
Yeah, so you get 7.
Minus,
Oh, it's -7. I didn't see the negative in front of the, it's -7.
yeah. So if you were to ask my opinion about what is holding you back, it's exactly what happened in this problem. You have the ability to do this problem very quickly, but it's the little attention to detail, the fact, yeah, there's a subtraction sign there. It's a big deal. It's like the difference between going right and
Yeah.
all right. So now you can also combine numbers, and I'll show you that here, or we'll look at an example here together maybe. Like terms are not just limited to variables. So if you see two numbers on the same side of the equation, you
Yeah.
combine those first.
And that would be x equals 6.
Negative
-6.
six.
-6.
Yeah. So let me throw up a problem here for you to try on your own, and you can, again, just, and the thing is, you have enough time to probably work it twice if you want. But go ahead and give this a try, please. Let me know.
Okay, so then negative 5K. So then negative, or just 3K.
Give me the final answer. Go ahead and work it all the way through.
5K. So K equals 5.
Okay, let's take a look here. So you've got minus 12 equals 3 minus 5K. Subtract 3 from both sides. So the 3 is positive. It's not, there's no positive sign in front, but it's assumed to be. And so that's negative 15 equals minus 5K. Divide by minus 5. K equals not 5, but what is minus 15 divided by negative 5?
Yeah, so then it'd be 5. Or 3.
Try again. 3. Yeah.
It's the easiest questions to get right that I'm missing.
So one of the things you can do is you can check your answer. All right. And I don't know how much your instructors talked about that, but when you check your answer, you're just putting the number back in for the variable. And so if you have time on a test or quiz, you'd want to do that.
Yeah.
You know, you'd want to say, okay, well, you know, is my answer right? Is 2 times 3 minus 3 times 3? Make sure you substitute in parentheses. You know, 3 minus 6 minus 9 is minus 12, and these are the same.
So then be all solution, or no.
No, the point is you check your answer.
Yeah.
So for the next problem, I don't want you to give me the answer until you've checked your answer.
Okay.
Okay, so I'm gonna give you a much simpler problem. Like there's no reason for you to get this wrong because you're not only going to solve it, you're then going to check your answer.
R equals 1.
And you checked it.
Yes.
Okay. -1 equals -3 times 1 plus 2 times 1. -3 plus 2 is -1. That is correct. All right, so let's just see if I can find a few more here to throw in front of you. Yeah, here we go. More like this. All right. It's another one for you to try, please.
R equals 1.
Okay, very good. All right, so I think you've got this down. The next type of problem that we'll see here is the distributive property. So you probably already know what this is, even if you're not sure yet. Distributive property is, let's say if something in parentheses like 5x minus 4, and you have a 2 on the outside. Do you remember what the 2 on the outside does to the stuff on the inside?
You multiply it in.
That's right. So it becomes 10x minus 8. What if you have a negative on the outside? Do you remember what that does?
It multiplies everything by -1.
Yeah, I like saying change the signs, but yes, it's the same. It's the same thing. -5x plus 4. What if you have like 3x plus 2 and it's -5 on the outside? What does that do?
Multiply everything by -5.
Right, so negative 15x minus 10. Good. Okay, so how does that impact problems we're doing? Well, let's look. Sometimes you have some problems here where you have to apply the distributive property first. So you have to first multiply in by 3. So tell me what the right side becomes after you multiply in by 3.
The right side becomes 9x minus 18.
Okay. And then 18. All right, so why don't you solve this from here, please?
Okay. Let's see. Plus 18, so 36, and x equals 4. X equals 4.
Correct. Good. Okay, so here's one to try fully on your own, start to finish. Again, you can always check your answer. Like if you, before you say, okay, that's the answer, you say, okay, 3 times 4, that's 12, 12 minus 6 is 6, 3 times 6 is 18. All right, so try this one, please.
Okay. So then that would be negative 30n plus, or negative 30n minus 30, so plus 30, so then n is -2.
So did you check your answer?
Plug in -2, -12, that'd be 8 minus 60 minus, yes,
You got net -2 as your answer, and you check that?
yeah.
Okay, so when I check it, 6 times -2 plus 6, that becomes -12 plus 6. -6 times -5 is 30. It's good. So the check is just as important as doing. Some instructors really, really, really emphasize the check. Yeah, that's kind of up to you if you want to do that. All right, now the next type of problems you'll see here is when you have variables on both sides of the equation. Does that sound at all familiar to you?
Yeah, then you have to move variables to one side.
Yes. Now there's a specific strategy to doing this that it's like the best practice. You can get away with not doing this, but you really should do it this the way I'm going to suggest, which is you move from the smaller to the larger. And it's in terms of number line. So like if you have 3 and -12, -12 is smaller than 3. Smaller means more to the left. Okay, so in this problem, you've got a 5a and a 4a, which is smaller.
4a.
4a. So the strategy is to move smaller to larger. Now, you may want to get into the habit of moving left. You may say, oh, I just always move left. That's not always the best way to do it. You can, but it's not the best way. Right? So from here, you would add 3 to both sides, and a equals -7. All right, so here is, let's take a look at a new problem. All right, so in terms of the variables, you got 3n, you got -5n, which is smaller.
Smaller would be -5n.
Okay, so in this case, you're moving left. You're moving left. So we have -16 equals -8. Oops, I forgot the insert there. That's really bad. Plus 8n. Okay. And now it's back to a two-step equation like you've been solving.
Okay. So then from there you would get plus 16, which would then give you you have 8 in n equals -1.
No, try again. What did you do to solve this?
Oh, n equals it's just be n equals 1, not -1.
Okay, so, and I'm getting the sense here, maybe you're not like getting all this down. Like the sign errors are super important. Like, I don't know how to like emphasize them, but like having the wrong sign is like, it's a disaster. You know, but, nevertheless here. So we've gotten in the habit here of all the problems we've been doing, we're moving the variable left, but that is not the case. Like typically you just look and say, okay, which is smaller, -4x or +2x? Well, add 4x to both sides. So this time the variable's on the right. 6 equals 12 plus 6x. Subtract 12 from both sides. -6 equals 6x. Divide by 6. And then the answer is -1 equals x, but this is awkward. You always want the variable on the left. So
Okay.
make sure you write your answer, the variable on the left.
All right.
All right, so here is, I'll have you try one here. And then I'll have you try a few more before we move on to more examples.
Okay.
All right, go ahead and try this one for me, please, and let me know what you come up with.
Okay. So for that one, you got 10. Actually, I'm subtract 4 first. So you get 3x, and then 10 equals 15. So x equals 5.
Equals what?
X equals 5.
6 = 5. Okay, did you try your answer?
Um.
Check it. That's really important to do.
Okay. I did now, and I think I got it right.
It is correct. Like there shouldn't, what I'm trying to get you to see is if you check your answer, there will be no question about whether you're right or wrong.
Okay. That makes sense.
All right, so here's a new one for you to try.
Okay. 10x equals 30. So then that gives you x equals 3.
Good. All right, so the way these problems get more difficult is they introduce more combinations of stuff that we've been doing. So here's a new problem for us to look at. So notice on the left side, you can combine like terms. On the right side, you can combine like terms. But when you do that, it becomes a two-step equation. I'm sorry, not two-step. It becomes an equation with the variables on both sides, which always reduces down to two-step equation. So these strategies we're learning where you combine like terms or you move variables from one side to the other, it's always to get everything down to either a one-step or a two-step equation
Okay.
like that.
All right.
So could you solve this from here, please?
So then, add 10, so you get 2, subtract 2, so you get 2x equals 2, x equals 1, and you plug that back in. 10 plus 2, negative 8. Or 10 plus 4, sorry. Add 10, so you get 2. And subtract this, you get 2x, so x equals 1. So then that's negative 10 plus 2 is 8. 4 minus 8. Huh.
So there's
Oh,
an
it's
error.
negative 1. I have it on the wrong side of
Yeah.
the equation. It's negative 1. X is negative 1. That's right. X is negative 1.
Yeah.
I
Alright.
had it on the wrong side of the
Yeah.
equation.
So it's easy to do exactly what you said, which is like, it's like, we've got, um, just be off by a sign. And that's maybe where you got to become the type of math student that's checking every problem. You got time. So take a look at this, give this one a try, please. Kind of more of the same.
Okay. So then 6n minus 8n is negative 2n, so negative 6n on one side. So plus 1, 9 plus 15 is 24. So n equals negative 4. So put that back in. Negative 16 minus 1, negative 17. Negative 24 plus 8. Where's my calculator? 6 times negative 4 minus 8 times negative 8. I don't think the calculator did that right. Negative 24 plus 8 minus 32. Maybe plus 32 plus 15. I did not do something right. I got n equals negative 4, but that does not seem like it would be right.
Okay, so on the right side, you have to combine 6n and minus 8n. What does that become?
Negative 2n.
Negative 2n, and then you got 8 and 15.
Yeah, so then you get 23, or yeah,
Okay.
23.
All right, so you got to move from the smaller to the larger. Which is smaller, 4n or minus 2n?
So then you'd add 2n to both sides.
Okay, so what does that become?
6n.
Okay, then you got to move the 1 over, negative 1 over.
You'd add it. Oh, it's just positive 4.
Okay, so n equals 4.
Yeah.
All right. Let me put another one up here in front of you.
Okay, so then 15. So
Are you allowed to use a calculator in the class?
yeah, so that's 20, 28 on the right side and 7r on the left side. So minus 7r. R equals negative 4. This one I'm sure of.
Would you
R is
check your answer?
negative 4, so negative 16. Plus 8 is negative 8, plus 5 is negative 3, and then only negative 4. Yes, I'm sure of it.
R equals negative 4?
Yeah.
All right, so 4 times negative 4 plus 13. That's negative 3, negative 15 minus 3 times negative 3. Negative 4, sorry, is also negative 3. Good, really good. Okay, so let me give you just a tiny bit more complicated one. See where you're at, see if you can do this, then we'll move on to kind of the last type of problems you'll see. All right, so go ahead and give this one a try, please.
Okay. Okay. So then you get 7p plus or minus 1 equal to 8p minus 8. Subtract 7p. You have p equal to 7. P equals 7.
Okay, so P equals 7. Did you check your answer?
42, 44, 51 minus 3 is 48. 8 times 7 is 8 times 8, so 56 minus 8 is 48. Yes, it's correct.
And hopefully you're seeing the value in the check. In the real world, you don't do anything without checking, because it's more costly than it is in your math class. But so the last like type of problem that you will see is something like what I'll put in front of you. And I'll work out a few examples here for you to see. So they just get more complicated. You can see that there's the distributive property.
Yep.
You can see that after I do the distributive property here, and this is where you're going in your class, you will then combine like terms, okay? And that's kind of the simplify step. That's to me, that's a simplify step. 6k minus 12 equals minus 3k minus 39. I would call that simplify because you're combining like terms, which is a simplified step. You can talk to your instructor. Now we're down to something that you have been doing all afternoon. 6k minus 12 minus 3k minus 39. Add 3k to both sides. So you get 9k minus 12 equals minus 39. Add 12 to both sides. Okay, and so you get 9k equals minus 27. Divide by 9, k equals minus 3, like that. So it's just more stuff, right? More of the same to do. So let me give you one that's not as difficult to try here. You want to do that distributive property stuff first, then combine like terms, then move stuff around like we've been doing.
Okay.
And you can always check your answer at the end.
Yeah. And 36v plus 36 plus 31. So 36v plus 31 equals 1 plus 6v. So then 30v equals negative 30v equals negative 1.
Okay, go ahead and check your answer just to make sure.
Okay. Yeah, I'm sure.
So if I were checking my answers, I wouldn't necessarily check them right away. I might like wait till the end of the test because sometimes there's a recency bias where you just want it to work out. And so that's another consideration. Like you may just work all the way through the test, get your answers, and then go back and check them all before you turn them in. Also helps you to not rush to turn in the test because you do every problem twice. All right, here's another one for you to try. It's a little more complicated because of the -7, but you're multiplying in by -7. You're combining like terms, you're moving stuff around. So give that a try, please.
Okay. from here. It's 42 minus 56n plus 3. 16 plus 5. So add 56n to 61 and is equal to plus 16. 58 plus 3 is 61 n equals 1.
Okay, and did you check your answer?
Negative 11 and then negative 40.
It's like I'd put the 1 in here first, then add this, then multiply. Use your order of operations for that.
Yeah, I'm sure. I'm pretty sure.
It is correct. Good. Okay, so hopefully you've given you some things to think about. I mean, you're probably like, that's probably what you see the next few days. Do you have math every day? What's your schedule like with,
So I have it most days. I just don't have it on Wednesday. Wednesday's like
okay.
a